Dear students, welcome to my class. I am Dr. D. Paradesi, Associate Professor from Department of Chemistry, SRM Institute of Science and Technology. In my previous lecture, I have explained about the basic principle behind the corrosion and what are the mechanism behind it. And I followed by the next lecture, I have explained about the corrosion control mechanism. So there are various ways we can control the corrosion. So the broad classification of corrosion and what are all the controlling mechanism. So those are all the things I have explained in my previous lectures. So this is the continuation of those lectures. So from this lecture, what are all the learning outcome? So corrosion control can be effectively carried out by two different aspects by the way of selecting the metal and how can we protect the metal from the environment. Okay, so those two things explained already. Now for this lecture, another way we can control the corrosion, that is called electroplating and electroless plating. So from this lecture you can learn what are the method to follow the electroplating and electroless plating, what are all the advantages, disadvantages and applications. Okay, so this is the just outline of my previous lecture. The corrosion can be effectively carried out, control can be effectively carried out by material selection, designing of metal, inhibition of corrosion, modifying the properties of the metal, and protective coating. I have covered all the four in the previous lecture. For this lecture, I will explain about the protective coating. So it may be carried out by electroplating and electroless plating. So let us see electroplating first. It's a very simple process. So depositing a layer of the metal by electrolysis over the surface of a substrate, which may be another metal or polymer or ceramic. So simple galvanization, I think all of you know that the same process. Galvanization is the best example for that electroplating. So metals like copper, gold, nickel, chromium, zinc are electro-deposited to give high performance material. So the purpose of electroplating is to prevent not only to prevent the corrosion by decorating the metal, decorating the objects. So this will provide a smooth, fine, uniform coating. However, it influences some factor. Some factors influencing this electroplating. That is the time and temperature, current density, the concentration of an electrolyte, and the basic nature of the metal. So why we have to make electroplating? It's very simple. To increase the resistance to corrosion of the plated metal, to effectively control the corrosion, to increase the chemical resistance and wear resistance, and the appearance of the metal and its hardness, and the look, that is decorative and commercial value of the metal. That's the reason the price of such kind of ornaments and all other things will be high. To improve the surface properties, to increase the strength of the objects. So these are all the objective of the electroplating. So it is primarily used to change the surface properties. That means abrasion and wear resistance, protection, lubricity, and aesthetic quality. That is very, very important. And sulfuric acid, copper bath are now widely used in the industry for electroplating. Let us see the mechanism in the upcoming slides. So before that, how the electroplating setups to be placed, that is on anode, on cathode, and on electrolyte solution, and the connection between the anode and cathode. Very simple setup. Anode, cathode, it should be connected via a battery. Electrical power supply is required in presence of an electrolyte. Okay. So what is the anode? Anode is connected to the positive terminal of the supply. Cathode is nothing but the article to be plated. That means base metal. So cathode is the base metal. Anode is the coating material. So the coating material is connected in positive terminal, and the base metal is connected in the negative terminal. Okay, now the external power supply is switched on. What happens? The metal at the anode is oxidized. So metal in the anode is oxidized. So it loses the electron to form the ions. Okay, then the cations associated with the anion in the solution, cations are reduced at the cathode to deposit in the substrate. I will explain in the slides with the beautiful diagram. Okay, so these are all the bath composition. This I will explain in the place of diagram. Yeah, anodic reaction, copper is oxidized with Cu2 plus 2 electron. Cathodic reaction, copper 2 plus accept the electron and form the copper metal that is coated. That is coated. Okay, right. So now look at, let us see. Yeah. Look at, this is the simple mechanism between the anode and cathode for the process of electroplating. Look at, so this is the copper electrode and brass electrode. So two electrodes are there, copper and brass electrode. Copper is to be coated with the brass electrode. Okay, so this is the electrolyte, that is nothing but copper sulfate solution. Now, what is the mechanism? Very simple. First step, ionization of electrolyte. So copper sulfate. Copper sulfate is the electrolyte. So copper sulfate dissociate. If you switch on the power, copper sulfate is dissociated into Cu2 plus and SO4 2 minus. So Cu2 plus is deposited here. Okay, then here SO4 2 minus ions are there. This minus SO4 is moving towards the copper electrode. Okay, again it forms to copper sulfates. React with the copper to form copper sulfates. So first step, dissociation of an electrolyte. Then by passing current Cu2 plus 2 electron, copper is reduced here. Then SO4 is migrate here. Again react with copper to form copper sulfate. Again this copper sulfate is dissociated into copper and sulfates. So this is the best method. If you look at the image here, so this is the anode, that is copper. Anode, that is copper. Here it is cathode, the metal substrate. The same mechanism is happened here. Copper sulfate solution, copper metal, and the substrate. If we connect via battery, and this is copper is deposited over here. Okay, so the same thing I have explained in simple way. Cathode means object to be coated. Anode, the coating material. Electrolyte, the solution containing ions of coating metal. Okay, power supply provide DC current. So simple way of understanding the electroplating process. Okay, so this is the image of copper plating or copper coated materials, pipes and bearings and some other objects. Okay, apart from that, the coating isolates the base metal from the environment. So very simple, you can easily understand once the coating is over. So metal is there, coating is there. Now after coating, the coating layer isolate the base metal from the environment so that the metal is protected. Okay, right. Next, in zinc plated suppose just imagine zinc is plated in a steel. Now the zinc corrodes preferentially, protecting steel. That is a simple mechanism. Okay, some other examples are also there. Chromium plating on steel, nickel plating on iron, zinc plating on steel, that is galvanization, silver plating on copper. These are all some other examples. Okay, now coming to the most important section, that is methods of cleaning objects before electroplating. That is very important. Just imagine a simple example. Suppose if you want to paint over a door, grill door. Okay, so in your home, how you will proceed normally? We cannot paint directly the window. That is iron rods. If you want to make a paint over in the window, the first what you have to do, you have to clean the surface, then only you have to make a paint. Simple. In our home, we are practicing like that. The same thing. If you want to do any electroplating, the metal, the object to be cleaned in a proper way. Okay, what are all the cleaning methods? There are 5 or 6 methods we have to follow. Depends on the objects. Now I will explain whole method. So based on the object, it will be slightly varied. Okay, first method, cleaning, solvent cleaning. So solvent cleaning is an organic solvent mostly. That it may be naphtha or chlorinated hydro. That is carbon tetrachloride, toluene, xylene, acetone. These are all the very good organic solvents. It removes oil and grease and fatty substances from the surface of the object. Okay, so this treatment provides a clean metal surface readily wetted by aqueous solution. That is very important. Readily wetted by aqueous solution, because which is required for electroplating. And the second method, alkali cleaning. So removal of old paint or old coating materials from the surface. Okay, even the same, simple. You look at again, some painting is removed or partially it is coming out from the object. Then what we have to do? We have to rub it. Okay, we have to use some salt paper or something. We have to rub it and we have to remove it. But here we can use one more method for the industry. Trisodium phosphate along with soap or else caustic soda will be used to clean such kind of cases. And then acid cleaning. So depends upon the objects. Once again, I'm telling. So acid means like hydrochloric acid or sulfuric acid or phosphoric acid used to remove rust and scale. So 5 to 10% of acid along with the inhibitor to remove the inorganic contaminants. So among the 3, phosphoric acid is very effective for the removal of oil, dirt and rust from the surface of the contaminants. So it also, another advantages of acid cleaning is it causes etching. So it does not only remove the dirt and oil and grease, it also create etching. Etching means it creates some roughness over the surface. If it creates a roughness over the surface, means after that if you are coating, it will be very effectively the metal will be coated. Whatever the coating material will be effectively fit on the substrates. You will get a very smooth coating. Okay, so the third on mechanical cleaning. That means removal of loose rust and other impurities from the. So this one you can use some brush. So normal brush we can remove the thing, or else by way of applying some sand or soap wash should give. Okay, so mechanical means manually you have to remove the unwanted materials over the surface of the metal to be plated. Then flame cleaning, that is heating the metal surface with a hot flame. Look at the image. Hot flame if you are using, then whatever the loosely adhering scale and moisture, it will be removed from the substrate. Okay, then another effective method is pickling and etching. Acid pickling. Acid pickling means scale removal. Scale removal means if you look at these objects, so it should be dipped in a alkaline solution, immersing the metal in an alkaline solution. What happened? So at a period of time, so the unwanted materials or scale will be removed. Okay, followed by it creates etching. So it is a dual advantage like acid treatment. Okay, so you will get this is the etching material. So you will get a smooth etching after the process. So etching is very essential. Once etching is done, after that you will get a smooth finishing. After if you are processing a electroplating method, then you will get a smooth and effective coating over the base metal. That is very important. Etching is essential one before plating. Okay, one more method is sandblasting. Nowadays this method is not widely used because some kind of issues, like first I will explain the method. Very simple. A metal surface to be plated. Okay, so some kind of, you look at this, so these are all the unwanted things. If you want to remove it, still it is persisting after such kind of acid alkali treatment, then you have to use this gun, that is a sand blasting gun. Okay, right. So this sand blasting gun, it releases sand at a very high velocity. So at this force gun velocity, this unwanted material will be coming out from the substrate. But this method is not widely used nowadays because it causes severe respiratory health issues, so that it is not safe. That's why this method is nowadays not used in industries. Okay, anodic coating. When the coating metal is anodic to the base metal, then it is called anodic coating. Cathodic coating means when the coating metal is cathodic to the base metal, then it is cathodic coating. Simple definition. Okay, so the example for this one is coating of zinc over iron, that is called galvanizing. We have already studied, even in my previous lecture hour also I have explained, so no need to go in depth. So two more different methods we have to learn in this lecture: hot dip galvanized steel and zinc plated steel. Okay, so what is the kind of mechanism behind that? Hot dip galvanized steel is effectively carried out by immersing a steel in a bath of molten zinc. That means molten zinc. Okay, you have to take a molten zinc, just to dip the steel in the bath. During this process, the zinc chemically react with the ion in the steel to form multiple zinc ion alloy. It's a alloy. So this alloy is very superior rust protection. This hot dipped galvanized steel is often used to make metal pails, handrail appliances, furniture, hardware, and tooling components. Just molten zinc is used as a solution object to be dipped. Okay, another one. zinc plated steel. It has been given a thin zinc coating for improved corrosion protection and an aesthetic silver or yellowish finish. Though the zinc is often applied via electroplating, other process that is called this kind of mechanism. For this kind of mechanism, zinc plated over the surface of the object for effect fastness, but also used to automotive parts for military equipments. Okay, so the difference between this hot dip galvanized and zinc plated, just look at, very simple. Coating is almost here hot dip means the thickness will be 40 to 100 micrometer. Here it is only 10 micrometer, 10 times lower than that. And durability, here it is very high, here it is moderate. Look at the object first. Okay, and then dull and rough finishing, here bright and smooth finishing. This is outdoor use for marine and other engineering related things. This is indoor light duty. So whatever we are using in our home construction and all other things, we are using zinc plated, not hot dip. So this may be used in mostly outdoor and engineering industries. So cathodic coating, as I said, it is the reverse of the anodic coating. So the example for this cathodic coating is coating of tin over steel. Look at the image here, anode is tin. So the reaction, it loses the electron and it is coated over in the cathode material. So just opposite to the anodic coating. So this is the objects. Inside the can plated with the tin. Inside the can it is plated with the tin. So these are all the objects. Before it should be removed, dirt and some impurities, it should be removed before plating. So overall the process can be explained in a schematic diagram, very simple. The first thing is we have to prepare surface preparation. So cleaning, rinsing, alkali treatment, acid treatment, followed by rinsing. Okay, so these are all the surface preparation. Once the surface preparation is over, then go for plating. After plating also you have to rinse the objects. Okay, so the main application of electroplating is PCB, that is a printed circuit board. It is used and used for coating over steel cable to increase the electrical conductivity. And the coating is explained in a schematic way. Copper plated steel, and these are all some of the objects coated with copper. And the advantages, as I said already, it is good corrosion resistance, improved appearance, enhanced wear resistance, economical for mass production. However, there are some limitations. Non-uniform coating on complex requires electrical power, that is very, very important. Environmental conditions also to be considered for plating. Okay, now let us move to the electroless plating, just comparing. So here external power supply is required. Here there is no external power supply is required. There is a major difference between electroplating and electroless plating. So depositing of noble metal from its salt solution on a catalytically active surface of a less noble metal by employing a suitable reducing agent without using electrical energy. That is a simple definition of electroless plating. Okay, so here also similar way we have to follow the cleaning process. So we have to clean the metal surface by the way of acid treatment, alkali treatment, etching, everything we should follow. Okay, then the metal and alloys like aluminum, copper, iron, brass can be directly nickel plated without any activation. For nickel plating, these metals no need for any activation. Okay, some other category we have to activate the metal. Say for example, stainless steel, definitely it should be activated by dipping in hot solution of 50% dilute sulfuric acid. Okay, so depends upon the substance and coating material, we have to choose the appropriate method. Now plating bath. So the plate, what is the condition for nickel plating? The soluble salt of metal like a chloride or sulfate to be plated. Okay, then reducing agent, formaldehyde or hypophosphites. Complexing agent like citrate, succinate. Stabilizer, thiourea, and cations of Pb, lead and calcium. Buffer, sodium acetates or hydroxide to maintain the pH. So this is the same thing. So what are the advantages of electroless plating over the electroplating? As I said already, no electricity is required, better throwing power, and plating on articles made of insulator, that also possible. Whereas in case of electroplating, it is not possible. For electroless plating, this is possible. Even insulator also we can use. Okay, right. Even irregular shape also we can perform. So some of the objects for the example of electroless plating. And what are the applications of electroless plating? It is used in electronic industry, especially for fabricating PCB, and galling, that is wear caused by addition between sliding surfaces. Okay, so it is used to prevent galling. And electroless nickel coating is used in decorative and functional work. Nickel coated plastic cabinets are used in digital as well as electronic instruments. So a lot of applications we have. However, the limitations are high cost of chemicals, slow coating, poor solubility of solution. So these are all the things to be overcome. So overall, the comparison between electroplating and electroless plating. So in general, if we want to do any coating, first we have to study the base metal. Based on the study of investigation of the base metal and the conditions, we should go for electroplating or electroless plating. Okay, so whatever it is, the effective comparison between those things are the main difference, that is here power requirement. Here power required, here power is not required, electrical power is not required. Coating thickness, here it is non-uniform, here it is highly uniform. Electroless plating is highly uniform. Complex shapes is difficult here, here it is excellent coverage. Deposition rate is very fast in electroplating, here it is very slow. Cost, our cost is lower in electroplating, however it is high due to the higher chemical costs. Okay, so the corrosion resistance is good here in electroless plating. It is very effective in the electroless plating. Students, hope you understand the mechanism of electroplating and electroless plating and what are all the advantages, how we have to make a pre-treatment of the base metal. That is very important in both electroplating and electroless plating. The pre-treatment of the metal object is very essential. We should follow the method based on the conditions of the metal. Okay, if we follow, then we can achieve a good definition of coating over the surface, either by electroplating or electroless plating we can achieve. Hope you understand the concept, student. Thank you.